This video is on the Pythagorean Theorem. The Pythagorean Theorem is used to find missing side lengths of right triangles. The formula for Pythagorean Theorem is a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. This picture shows a right triangle. The legs of the triangle are what form the 90-degree angle. So here and here are legs of the triangle. Directly opposite of the right angle is the hypotenuse, which is always C. It's always the longest side. For this example, we are given the legs with a length of 4 and 7. We are asked to find C. So using our formula, we have a squared, so we're going to use 4 as a, 7 as b squared equals c squared. Now we're going to follow the steps to solve equations. 4 squared is 16, plus 7 squared, which is 49, equals c squared. 16 plus 49 is 65. Now, in order to take the square root to find the value of c, we take the square root. When we draw the square root on both sides, we are really putting in a plus and minus sign because it could be negative square root of 65 or positive. The reason it can't be negative is you cannot have a negative side length. So the answer is the square root of 65 equals c. Sometimes you will need to simplify the radical, and other times you will have to make it into a decimal form. The square root of 65 does not simplify, therefore the answer to C is the square root of 65. For the second example, we are given a side length of a leg of 4 and the hypotenuse of 5. That means we're either looking for A or B because the legs are interchangeable. So we are going to write a squared plus 4 squared equals 5 squared. We keep a squared as a squared, 4 squared is 16, and 5 squared is 25. Now we're going to follow the steps to solving equations by subtracting 16 on both sides. Therefore, we get a squared equals 9. The last step we do is we take the square root on both sides. Again, we would put in the plus or minus sign, but because it is a length, we don't use the negative. So the value of a is 3. This leads us to a special thing called Pythagorean triples. This Pythagorean triple is a 3, 4, 5 triangle. Pythagorean triples, if you can memorize them, it helps you not have to figure out what the side lengths are by using the Pythagorean theorem. You can just know. A 3, 4, 5 triangle, you can use scale factors to multiply them. So it could be a 6, 8, 10 or a 9, 12, 15. This is probably the most common Pythagorean triple in geometry. The next most popular Pythagorean triple that you will see in geometry is a 5, 12, 13 triangle. Some of the others Pythagorean triples that you may see would be a 7, 24, 25, an 8, 15, and 17, and a 9, 40, and 41. Again, the most common ones you will see would be the 3, 4, 5, and the 5, 12, 13. Now it's your turn to try some problems. Number 1, A is 4 and B is 5. Find the value of C. Number 2, A is 7, C is 10. Find the value of B. And the last problem, number 3, B is 40, C is 41. Find the value of A.